How to debug multithreaded C++ applications with Valgrind. Are you struggling with bugs in your multithreaded C++ applications? Debugging can be tricky, especially when dealing with multiple threads. Today, we will discuss how to effectively use Valgrind to tackle these issues. First, let's talk about the tools Valgrind offers for multithreading. The primary tool you will want to use is Helgrind. This tool is specifically designed to analyze thread interactions and can help you find race conditions and synchronization problems. Another useful tool is DRD, which also detects threading errors and works well with programs that use POSIX threads. Before you start debugging, make sure to compile your C++ program with debugging symbols. You can do this by using the -G flag during compilation. This step is essential as it allows Valgrind to provide detailed information about your source code. Once your program is ready, you can run it under Valgrind using Helgrind. The command you will use is Valgrind is equal to Helgrind followed by the name of your program. This will enable Valgrind to monitor how your threads interact. It will report warnings about data races and inconsistencies in locks. If you prefer to use DRD, the command is similar. Just replace Helgrind with DRD in the command line. This tool will help you find race conditions and deadlocks in your multi-threaded applications. Since multi-threaded bugs can be subtle and depend on timing, it is a good idea to run your program multiple times under Helgrind or DRD. This approach can help catch intermittent issues that may not appear every time you run the program. In addition to threading errors, you can also use Valgrind's memcheck tool. This tool is great for identifying memory errors such as leaks and invalid memory accesses, which are common in C++ applications. Using memcheck alongside Helgrind or DRD provides a more thorough debugging process. For the best results, remember to compile your code with debugging symbols and without optimization. This practice helps maintain a clear mapping between your code and the output from Valgrind. After running Valgrind, carefully review the reports it generates. Look for issues like missing locks or incorrect lock usage, and address these problems in your code. Once you have made fixes, rerun Valgrind to ensure that the issues have been resolved. It can also be helpful to integrate Valgrind runs into your regular testing process. This way, you can catch any regressions early on. Understanding threading concepts such as mutexes and locks will help you interpret Valgrind's output effectively. The reports will typically include stack traces that show where problematic memory accesses or thread interactions occur. This information is key to pinpointing the exact locations in your code that need attention. By systematically applying Valgrind's multi-threading tools and analyzing the reports, you can effectively debug complex multi-threaded C++ applications. This method will help you fix bugs that are often difficult to detect through standard debugging techniques.